in yesterday's class, we looked into the concept of classes and objects, and uh, we saw how to add uh, variables dynamically at runtime into a class and all that. And also we have seen the concept of built-in functions. So we have this has attribute and get attribute, and also set attribute and delete attribute. So these are the built-in functions. As I said, please do not confuse from built-in attributes and built-in functions, because this is an essay question. Okay, so built-in functions are has attribute and get attribute and all that. I have shown all these four applied in a program to a class. So we have checked out what will be the concern output whenever you are using has attribute. So whenever you're using has attribute, it will return a Boolean value, either true or false. So if the attribute is there with the object, then you get a true, else you'll get a false. Okay, so in the similar way, get attribute will retrieve the value of the attribute. If there is no attribute at all, then some error code is displayed, which is user defined. So you can define your error code yourself. And the next method is set attribute. So the set attribute will create a new attribute and initialize certain value to the attribute, to the variable. If the variable is not present, it will create one and assign. If it is, if the variable, okay, so the instance variable is already existing, then it will make modifications to it with the concerned value that you are passing into set attribute. And the get attribute will get the attribute for you. Okay, fine. So the del attribute will actually delete the instance variable. Okay, here we are actually deleting v1. So after deleting, if you try to access v1, so you'll be getting a name error saying that v1 is not defined, meaning that v1 is deleted. So now let us look into the concept of built-in class attributes. So there are these attributes, like you can see, these are dunder attributes. So there is two underscores in the beginning and two underscores at the end. So these are special attributes which are built-in attributes. Generally, the built-in functions or built-in attributes are special attributes, and special methods are like dunder. They'll be having two underscores in the beginning and two underscores at the end. And I have put a dot in front of this. You can see, like, before the dot, you will be associating the name of the class or name of or the object. Okay, so after that only you have to give this attribute. And so dict attribute gives the dictionary containing the classes or the object's namespace. So you can give the name of the class dot underscore underscore dict underscore underscore, or else you can also give it for the object. For whatever it is, it will give the, if you're giving class name, it will give the dictionary containing the class namespace, else it will give the dictionary containing the object's namespace. So you know dictionary, right? It's a key value pair. So in that format, it will give you. Okay, right. And the next one is doc. So you already know what are doc strings. So it will give, this attribute gives the class documentation string. So we have seen the doc strings for the functions, right? I have given you which are written before the body of the function. If it is single line documentation, you'll be putting in single quotes, else multi-line you'll be putting three quotes and then give multi-line documentation. So which will be a description of the function, right? So that we have seen in the functions concept. So in the similar way, like you can give documentation string for the class also. So if you are specifying any documentation strings, like describing the class, what are the data inside the class and what are the methods inside the class, and so if you want to be specific about describing the class and give a doc string, then to extract that doc string, you will be using this doc attribute. Okay, so underscore underscore doc underscore underscore. And the next attribute is the name attribute. So we have seen all these attributes in the modules concept. If you just recall, we have seen all these attributes in the module concept. Okay, now this attribute returns the name of the class. Okay, and then module, this attribute gives the name of the module in which the class is defined. And coming to basis, because we are talking about a class will be having there can be inheritance of the class also, meaning that there will be a base class and the derived class and all that. So for the, in case if a class is derived from another class, so the base class name will be displayed over here. Okay, so these are the five built-in class attributes, and Herein in this slide, I have shown how to use them in the program and what will be the concern output. Okay, fine. So this is the class A. This is the class A, and here you can see that this line is the doc strings. So I have given a doc string for the class A. So I said this class takes two instance variables, or you can say this class is an employee class, or you can say this class is a student class, or you can say this class is a banking class wherein certain methods are there. So all the description, anything, it is your wish, whatever you want the other programmers to know, or anything you can put over here. Okay, so these are the doctrines of your class. And then this is the init method where the initialization of the instance variables happen. So this init method is taking two arguments. The first one is v1 and the second one is v2, and we are initializing them. So as I said, self.v1, so the instance variables are initialized. Okay, fine. And there is another instance method over here in this class, which is a display method. So the display method will be displaying the two instance variables. That's it. It's a very simple class with one doc string and then the init method and then the display method. So this is object creation and initialization happens whenever you make your class as a function, like putting some parentheses after it and passing arguments. So this will actually internally call the init method, and then this 10 is passed into v1 and 20 is passed into v2, and these two variables are initialized over here. And in the next case, I am calling the display method. So when I call the display method, so you can see it in the output. So v1 is equal to 10 and v2 is equal to 20. Okay, so the initialization and the display method is displaying it fine. Now let us look into how to use the dict attribute. Okay, so I already told you, like, it should be a fully qualified name. So I need to give the object, or I need to give, it's okay if I, even if I give a dot, it will work. Okay, because it is just to give the namespace of a class or an object. So herein I have taken the object. You can also try it with a dot underscore underscore dict underscore underscore. So when I said object, okay, so this is the reference variable of the object. So when I said obj dot underscore underscore dict underscore underscore, so you can see here in the output, it is saying object dictionary. So this is what I have written in the print statement, and later it will print the dictionary format of the object. So you can see it is printing the dictionary format of the object. So this is the key value there. So the key is 21 and the value is displayed over here. There is a column. And you know that in dictionaries, the order of the elements is it's an unordered. Okay, so that's the reason why I got v2 first and then v1 later. Right. And in the next case, I said like obj dot underscore underscore doc underscore underscore. So this will return the doc strings. If there are no doc strings, it will return nothing. Okay. So here, since I gave the doc strings, it is giving me the doc strings. So whatever I have written here is printed over here in the doc strings. Okay. So this is the next attribute. And the next one is the name. Okay. So here we want to extract the name of the class. So I'm saying a dot underscore underscore name. So it is saying a is the name of the class. And then we are saying object module. Okay, so we want to know that in which module this program is written, and generally we know that it will be written in the main module. So it is showing me the main module. And here we want to know that what is the base class of A, meaning that what is the super class of A. Okay, so A underscore basis. Okay, so we want to know that what are the super classes of A. As of now, do not worry on what is the superclass and subclass. Next topic is that in your next unit, we'll be discussing about inheritance, wherein you can derive another class from one class. For example, say I'm having class A. From A class, I can derive another class B, meaning that what does it mean by deriving and intent? So what all are the methods and attributes that are available in A class will also be available in B class. Okay, with the B's own functionalities, meaning that with the plus B's B's own data members and B's own methods. Okay, including the methods and data from A, B also will have its own methods and data. So such kind of concept is called as inheritance, when A is considered to be the superclass and B is considered to be the subclass. Okay, the object oriented programming means that there are principles, right? Object oriented programming principles. So Python is an object oriented programming paradigm. It is not like C, which is procedure. Python is an object-oriented programming. Recall from the first unit wherein I have discussed this. Okay, and object-oriented programming principles are abstraction, encapsulation, inheritance, and polymorphism. All these principles are make up the object-oriented programming. So one of the very important principles is inheritance, and Python supports inheritance, and the benefit of inheritance is reusability. So with the use of underscore underscore basis underscore underscore, we are checking what is the base class. Okay. So here the base class is object class. Everything it is object is the super class. This is regarding the built-in attributes. So the next very important concept is garbage collection. So unlike C programming and C++, okay, C and C++ are certain programming languages where there is no automatic garbage collection. Meaning that, for example, in C and C++, you do have this dynamic memory allocation like malloc, calloc, and all that, right? So what you're doing after you allocate memory, it is the responsibility of the programmer to actually free the memory. So you do have another method in dynamic memory allocation, which is the free method. Inside the free method, you will be passing the pointer, right? So this is what you have you have been doing in C program. So now what happened is, now the responsibility of freeing the memory is also on the programmer in the C and C++ programming languages. The programmer is actually burdened. Okay, so that is actually a problem. So you can say those are the drawbacks in C and C++, where really the programmer have to think of rather than concentrating more on the logic of the coding, you also have to put some concentration on freeing the memory. So what happened is, in later programming languages, which are the advanced versions of the programming languages like C and C++, what happened is, the automatic garbage collection concept is introduced. Now allocating the memory and deallocating the memory. So deallocating the memory is not in the responsibility of the programmer. The programmer need not worry about deleting the memory or deallocating the memory. So what happens is, in Python also, Java also supports automatic garbage collection. Even Python also performs automatic garbage collection. What is automatic garbage collection? That's what I gave you an explanation now. Okay, so the programmer need not free the memory. Okay, by using the free methods and all that, you have these free methods in dynamic memory allocation. In DMA of C programming, you have calloc, malloc, and then free and realloc and all that you have. So it is your responsibility to free the memory, but here it is not your responsibility. The Python virtual machine, okay, so will take care of freeing the memory. And this means that it deletes all the objects, both built-in or user-defined, automatically when they are no longer needed, and that have gone out of scope to free the memory space. I'll show you in the program what does this mean. Okay, so the process by which Python periodically reclaims unwanted memory is called as garbage collection. Okay, so and garbage collection is a daemon thread, or else you can say that it is a background program, or else we also call it as a daemon thread, which runs in the background. Okay, so with daemon thread just understand that it is a background program. Okay, so which will be running constantly at the background to see that whether any object is going out of scope, and if any object is going out of scope, then the memory is reclaimed or garbage collected, so that the memory can be reused, and because the memory is limited always. Okay, so you always have to free the memory so that the new objects can be created. If you're not freeing the memory, what happens is like memory stack overflow, like with the memory not sufficient, such kind of errors you will get. So every time you have to reuse the memory. Okay, so you have to keep deleting the unwanted objects or the objects that went out of scope, and you have to reclaim the memory, because it's not infinite, right? Memory is not infinite. Memory is finite. Okay, so it is 2 GB or 3 GB or 4 GB. So you always have to reclaim the memory so that it is further used. So this is a very, very important concept. Okay, garbage collection is a very, very important concept. Else what happens is, if the memory is not reclaimed, there will be so many dangling pointers, or there will be so much of memory occupied, and when they are not used also. So what happens is, automatically after consecutive days, after consecutive time, your memory will be full, And whenever you want to execute new programs, objects will not be created. So it will say that objects will be created only if there is memory in. If there is no memory, objects cannot be created. So it is very important that the garbage is collected, and Python virtual machine is having this automatic garbage collection program, which actually runs in the background to periodically reclaim the memory. So let me show you this in a program. Start from here. So I'm starting from here. So you have this class A. Inside the class A, I just have written one self, and I would have also written pass over here. So there is a display method wherein I'm just printing hi. Okay, so not very important. So but I just want to show you that there is a class because I need to create an object of the class. So here I have created an object of the class. This is the first object. Okay, so say I'm having a counter over here. Say I'm having a counter over here for the class A. So this is the counter, and for what only? For this is the counter for class A. Okay, and as soon as an object is created, this counter keeps updating, incrementing. Okay, so at this particular point of time, I have created an object, so the counter is 1. In the next statement, what I did, I have created one more object. Okay, so obj1 is equal to obj, meaning that this obj1 is also pointing to the object. So how many objects I have created? 2 objects I have created. As soon as an object is created, the counter keeps incrementing. Okay, and then here again I have created one more object, which is obj2. So whenever I create one more object, so the counter keeps incrementing. So now I have 3 objects which are pointing to the same object A. Okay, of the class A. Now let me show you this. Okay, so there is one method over here which is reference count, get reference count, and this is in the sys module. So that's the reason why I have imported the sys module. Okay, to use the methods and attributes inside a particular module, you have to import them. So this concept I have shown you in the modules part. Okay, so from the sys module, I have imported this method and I'm passing this obj to get the reference count of the object. So I got 4. Always this get reference count will give 1 extra. Okay, so that's why that's inbuilt thing. We cannot do anything. So I got 4 over here, and I am using this reference counter. So there is another way to know that reference counter. So another way is like importing the C types module. So inside the C types module, I'm having this method. So which is C underscore long dot from underscore address and the ID of obj. So which will give me the count of objects. Okay, so as you can see that, so I'm getting the count of objects to be 3. Okay, so this will give me the exact count, but from the system module, get reference count will give me 1 extra. Okay, so that's there. So I got 3. Now in the next case, what I did is I have said delete object. So I said del obj. So then the object is deleted. If you want to again find out the reference count, so you can see still there are 2 over here. Example equal to so I'm saying S is equal to Sudha. Okay. So I said S is equal to Sudha. Okay, so this is an object, right? And this is the reference variable. So what happened? Sudha is occupying some memory inside the virtual machine, and S is the reference variable. And after that, I said S1 is equal to S. Okay. So what happened? I have got one more reference variable which is pointing to this object. Okay. In the later case, I said S2 is equal to S1. Okay. So this is okay. I said S2 is also pointing to this object. Okay. So now how many objects are there? These objects are there. Okay. So now when I say del S, what happens is this reference is gone. Okay, and again said del S1. So this reference is also gone. Now I said del S2. Okay, so this reference is gone. Now this object which is Sudha is not having any references. Okay, so it's not having any references. Now this memory that is occupied by Sudha will be deleted. Okay, recycled. Okay, so this memory that is occupied by Sudha will be reclaimed. So this is what is called as garbage collection. till I have S2. For example, S2 is still there. I did not delete S2, but I have deleted S and S1. Okay, then Sudha will still exist in the memory. Okay, when all these three reference variables are deleted. So I said del S, okay, one reference variable is gone. I said del S1, another reference variable is gone. When I said del S2, another reference is gone. Now this object is hanging in the memory without any reference variable. How can you get to Sudha other without having the reference variable? Okay, so that is not possible. So that is when the garbage collection comes into the picture and reclaims such kind of objects. So here when I deleted S1 and S2, all the three reference variables are deleted pertaining to the object Sudha. Now what happened is this object is out of scope, meaning that it is not referenced by any reference variable. So such a kind of objects are reclaimed. So this is what is called as garbage collection. Even if it is having one reference, it still exists in the memory. But when all the references to the object are removed, then the object is reclaimed. So this is garbage collection. This is clear class methods and static methods. So this is the last topic. With these two topics, your third unit will be over. And in tomorrow's class, I'll start your fourth unit. So now coming to the class methods. What are the different methods that we have seen so far pertaining to the class? Pertaining to the class. For example, I said class A, right? What are the methods that we have seen so far in the class? What are the types of methods that we have seen so far?
Instance methods.
Very good. Very good. So we have seen only one method, which is the instance method. Okay. Now there are other kinds of methods. This is an essay question. Explain different methods of a class. Okay. So the first is the instance method. So you have to show program showing the instance method. The instance method definitely need to have a self as the first argument. Okay. The second kind of method is the class method. Okay, so what is a class method? So the class methods are different from the ordinary methods, meaning that the instance methods. What is the difference? First thing is they're called by a class. How instance methods are called? Instance methods are called with an object reference, right? So you're saying obj dot some display or whatever you're saying. But class methods will be called by the class name. Okay, and the second difference between the class method and the instance method is that the first argument of the class method need to be CLS. What is the first argument of your instance method? The first argument of your instance method is self. So this is the difference between your class method and the instance method. Class methods are like class variables which are associated with the class. Instance methods are pertaining to the objects. Okay, like your object instance variables. So there are two kinds of data and two kinds of methods that can be there in a class. The first one is the instance variables and instance methods. The instance variables and the instance methods are pertaining to the object. You can access them only through an object. You have to say obj and then only access them in case if the object name is obj. Now coming to the class variables and class methods, the class variables can be referred with the class name, and the class methods can also need also to be referred with the class name. And another difference between the class method and the instance method is that the first argument of the class method need to be CLS and the first method of your instance method need to be self. Okay, right. So whatever is common across the objects, that code you can return into the methods. So what are class methods widely used for? They are used for factory methods. What are factory methods? Okay, so which instantiates an instance of a class during using different parameters from those usually passed to a class constructor. So it is similar to the class constructor. If you want to do something different other than initialization or instantiation in the init method, you can write a class method. So how do you write a class method? So the class methods are marked with the class method decorator. So what is a decorator? Meaning that at the rate class method. So you definitely have to write this before the class method. Okay, so before the class method, you have to give an indication that it is a class method by giving the class method decorator. And what is a class method decorator? So it is at the rate class method. So let me show you how to create the class method in a program. So here I have a class and the name of the class is rectangle. Okay, I have a class and the name of the class is rectangle. And this is my init method wherein I am initializing the length and breadth. So I'm taking two arguments, so which is length and breadth, which are represented with L and B. So I'm initializing the length and breadth for the object. Okay, fine. And this is an area. Area is the instance method. Okay, so the area is the instance method. You can easily identify because it's having a self as the first argument. Okay, any method that is having self as the first argument is you know that it is an instance method. You are writing, right? We are writing it. We are making it as an instance method as per the application. And then I'm returning the product of the L and B, which is nothing but the area of a rectangle formula. So I'm saying self.L into self.B. So this is what I'm returning if the area method is called. So area method is an instance method. Now just take a look at this part. Okay, so this part is nothing but your class method. As I said, like class methods, before writing the class methods, I need to have the class method decorator. So at the rate class method, everything need to be lowercase over here. So this is considered to be the class method decorator. So ఖచ్చితంగా మీరు at the rate class method అనేది ఇవ్వాలి. You definitely have to give this at the rate class method. And then the method, it is a method. So every method will start with a def keyword. So I'm saying def. And this is the name of the class method. And as I told you, the difference between the class method and the instance method is the first argument. The first argument in the class method is CLS. So I'm giving CLS followed by the rest of the arguments, whatever you want to pass, you are passing. So here I'm passing side, and so wherein I am using the formula of a square over here, side into side. Okay, right. So there are two instance variables. So what does this class consist of? This class rectangle consists of two instance variables, which are L into B, and I have one instance method which is area and one class method which is square. Now this is where I'm creating my object and instantiating my instance variables. So I have instantiated my instance variable which is L and B. So I said I passed 10 to L and 20 to B. And then now I'm calling the square method. So how I have to access the class methods? I can access the class methods only with the class name. So that's what I told you here, right? So how do I access? Okay, so first they are called by the class name. So you can see that over here. So I have to call it by the class name. So what is the class name? The class name is rectangle. So I'm saying rectangle dot square, and only one argument is enough. Okay, so I'm converting the same program where length and breadth is same, so then automatically it becomes a square, right? Because for square all the sides are same. So I'm saying I'm passing 10 over here. So in this case, like I'll be getting 100.
Ma'am, your voice is breaking.
Okay, is it okay now?
Yes, ma'am.
Okay. So for square, all the sides are equal. So I'm passing only one argument, which is 10. So 10 into 10 make up to 100. I'm getting 100 on the screen. In the next case, I'm calling the instance variable, which instance method, which is area. So how we have called the instance method? I will call it with the object reference. So what is the object reference? S. So I'm saying S dot area. So you can find all this difference. First difference ఏం చూసారు? Class decorator use చేయాలి. Okay, so if you want to write a class method, so you have to use a decorator. Okay, so this is the first one. Second difference, what did you see? With the first argument. Okay, so you are saying your second difference you are seeing with the first argument. Okay, so for the first argument of the class, you are using CLS. And the third argument is your third point is like you have to call it with the class name. Okay, so how you are calling it? You're calling it with the class name. Okay, so these are the three differences that are there from the instance variable between the instance variable and the class instance method and the class method. Is it clear, girls?
Yes, ma'am.
Yes. Now let us look into another program wherein all the class method
by class name.
So by the class name, right? So what I did is I am directly calling the class name. This is this is possible. So I am saying rectangle dot a square. Okay, and I have passed 10 into it. So now this method is called where 10 is given to this particular side. Okay, now I am saying written CLS side comma side. Okay, so what is there inside? 10 is there inside, right? So now when I say side comma side, so this init method is called. Okay, and for L, 10 is assigned. This L takes 10 and this B takes 10, and 10 and 10 are assigned. Okay, okay, initialization is over and an object S is created. Okay, in the next case, now what I'm doing is I'm calling the instance method, which is area, okay, by using the reference variable. So this also is possible. Okay, topic of your third unit, which is static methods. So this is the third kind of method we are seeing. Okay, so the first one is the instance method, second one is a class method, and the third one is the static method. Okay, so static methods are special case of methods. Any functionality that belongs to the class but does not require the object is placed in the static methods. Okay, right. So you will be choosing based on your requirement of your application, you will be choosing whether to make a method static or class or instance. So that judgment the programmer need to make. Okay, right. And the static methods are similar to the class methods, but the difference in the static method you have to put this decorator, which means that enter static method. For the class method, you are putting class method, but here you are putting static method. Okay, and another difference is that okay, so they are just like normal functions, and as you can see inside the program, so I have written, okay, so practically see it. You won't be having a self or you won't be having a CLS. This is the next difference. Okay, Manaki, in the instance methods, what you're doing, you're giving a self as the first argument, right? Inside the class methods, what you're doing, you're giving CLS as the first argument. But the static methods will not have a self or it will not have a CLS. So this is the difference. Okay, so the difference is that it will not have the self or it will not have the CLS. Nothing it will have. Okay, right. And so let me show you how this is executed. So this is a program wherein I'm having a, so the difference Adhan cheskondi. The first difference ఏంటంటే between the other methods and the static methods. The first difference is that you will be putting a static method decorator, and the second difference is that the first argument in the static method will not be self or CLS. Directly the arguments will be there. Okay, right. Now let us look into how to work with this particular program. Okay, so now what is the how to work with the static methods? So this is the class and with the name choice. Okay, inside this class I'm having the init method which is doing the initialization. So here I have a, so you can see that I am having a list. Okay, so what is a list? The list is of subjects. Okay, so PP, data structures, English, maths to EC, and I just have taken all the subjects that you are studying. Okay, put D. Okay, so what is D? Your digital electronic subject, which was there earlier in your syllabus. Later on, it was replaced with data structures. But I have initialized the subjects. So what is subjects? Subjects is a list. Okay, so which will be having all this list. So this is my choice name of the class, and then followed by parenthesis. Inside the parenthesis, I pass the argument, which is subjects. Okay, fine. Now subjects is initialized. So this is your init method. And this entire part is your static method. Okay, so this entire part is your static method. So what is there before the static method? I have put the static method decorated. And it's a method, so it will be having that keyword, and then this is the name of the static method. Validate underscore subject. This entire thing is the name of the static method. And what it is taking subjects. The list of subjects it is taking. Okay, it is not taking any self or it is not taking any CLS. Okay, it is directly taking the arguments. So static methods are like your ordinary functions. Okay, so that you write outside your classes and the main program, right? So it will be similar to that. And inside this static method, we have written certain logic. So what I have written is, I said DE in subjects. Okay, so you know this in operator, which will check whether it is there in the list or not. Okay, so if DE in subjects, then we are printing that DE is no longer 1 2 subject. Okay, else we are writing true. Okay, so this is what I have written the logic inside the static method. What you have to understand is how to write a static method. So you need to put it can be any of the programs. Okay, just learn the syntax. The first thing is you need to put the decorator, static method decorator, and the next thing is like it will not have the self cost ELS as the first one. Okay, now what I have written is I have written a logic to call this static method. So I'm saying if all, so you know what is all method. Okay, so then I'm passing this, I'm calling this static method. So I'm saying choice dot. So I'm calling it with the class name. So I said choice dot validate underscore subject. This is the name of the static method. And I'm passing, okay, so I'm taking one by one subject from this subjects list, and then I'm passing it into it and checking whether it is true or not. Best, we are iterating a loop over here, right? For I in obj dot subjects. Okay, what will be I initially will be the first one in the list. So I will be PP. Okay, so PP is now passed. Okay, so PP is now passed into these subjects. Now we are saying, okay, so whether it is there in the subjects or not. So for everything it will return true, except for if DE in subjects, then it will return this one. It will print this one, and the program will end, because all will only execute. This print statement will execute only if all these returns will be true. If any one is false, then this statement will not execute, because I didn't write any else over here. If there is an else, that will execute. I didn't write any else, so it just stops over here. This if is not satisfied, so this print will not happen. Is this program clear, understood or not?
Yes, ma'am.
Okay, what we are doing, we are iterating through the list over here. So first PP is taken. So PP in subjects. Okay, so we are saying this if condition will not satisfy. So it comes to the else part and it will return true. So for PP, I'm getting a true. Okay, and for the other subject like DS, I'm getting a true. English, I'm getting a true. For M2, I'm getting a true. For EC, I'm getting a true. For BE, I'm getting a true. For IC, I'm getting a true. But for DE, what is happening? I'm getting, so I'm printing if DE in the subjects because it's there, right? So what I'm getting, this if condition over here is becoming true, and what happened? This statement is executed. Okay, and it will not return true, meaning that there is a false. So now what happened? This if statement, entire if statement has become false. So this statement will not execute in this case. Now, when I remove the DE from the list of the subjects, when I remove the DE from the list of the subjects, now it is saying you are allocated these subjects for your 1 2 and all that. So here I am showing you this one, because there is no DE over here. This if condition will never become true. Okay. So every time one subject is passed and we are getting true for all the subjects. So that's why this if becomes true, and this statement will execute. You are allocated these subjects, obj dot subjects will be listed, printed over here. So is it clear, ma, everyone?
Yes, ma'am.
Yes, ma'am.
Yes. Okay, so that's the end of your third unit. And in my